So these tools here, who knows what they're called? I sure as heck don't know. IPBS, India Papa Bravo Sierra. Well, I've got a clue what that means, but it looks like a homemade tool. Here's another one. We got 3 of them. What these are used for is these are used to take the bits out of our Frick sawmill blade. So I'll send you a link to one of the videos we're doing this. You crank these in here, you pull on it, it pops out the shank and it pops out the bit. The problem here is they break off. This little piece here is broken off, needs to be replaced. This one here has got none of them on it, needs to be replaced or made up. And the same, somebody tried to make one for this, fail, because the metal's a little bit too thin. It's like 1/8 inch steel instead of 1/4 inch. So what do? I'm not exactly sure, but we'll figure something out. So what I'm planning on doing is I'm taking a look. These holes are a little bit smaller, about 1/4 inch. Piece of 1/4 inch rod. I could take these and bend them. I might do that. I could also take this little piece of 3/8 inch rod and turn it down on the lathe and then put it together that way and bend them. I'm not exactly sure. What Pete did with this one is he peened over this edge here so this didn't fall out. Actually, that's a pretty good idea. So maybe a simple farmer solution would be peen over the edge and then we're in good shape. But, you know, we're like trying to be a machinist. I'm not a machinist. So we'll try something a little bit different that sort of looks like this and we'll see how it goes. So just to start off with, real quick and easy, what do we got here? What do we have here? It's interesting because it's 0.220. What? A little bit less, yeah. 220, 215. So it's under 1/4 inch. So I could take this and turn it down a little bit and go from there. I'm not quite sure. I could turn this one and go down some. We'll figure something out. Additionally, the way this one is, if you look at this, the distance here to here, what do we got here? This is almost 2.5 inches. We got another inch here, 1.5 inches. So I need something 2.5, 3.5, 4. This has got to be about 1 inch, about 5 inches. So I need 5 inches of material. So easy peasy, nice and easy. I could take this. I might just try this. Take this, turn down about 5 inches on here, and then we'll go from there. So let's crank up the lathe and see what we can do. All right, I think we're ready to get cracking. So everything I've learned about using a lathe in a Bridgeport mill, I've learned on the internet. Actually, that's pretty much true. But what I have learned, and I've paid attention, there's some really good videos out there, is short sleeves, watches, take all the stuff off, because it's like a power takeoff on a tractor. And when something catches it, it'll be really embarrassing because it goes flying, tears your arms off and stuff like that. Lots of blood and guts and gore, and I'd rather not have that today. So what I did here, you can see, we took this little 1/4 inch rod and I want to turn it down a little bit. So I put it in this 3-chuck jaw. I've already has it in the end of it. There's a small hole drilled in it. So with that small hole drilled in it, we can put a little centering thing in here. This will keep it from whipping around. Crank it down. A little bit of tension on this, don't go crazy, okay? And now when you turn this on, you'll see this will stay true here because it's got ball bearings in it. And this is true. There's still some flopping and flipping in the middle, but all I'm gonna do is take off 10 or 20 thousandths to make a thinner piece of metal. So I don't really care. Additionally, I'm gonna start 1 inch in because that's how far that one piece is where I'm gonna put the tab on. It's not really critical how far in you go, that's for sure. So I'm not gonna, you know, we could measure it to 1/1000th of an inch. That's a waste of my time. And time is important. So real quick and easy, there's about 1 inch. So that's what we're gonna do. So let's see what happens. Start it up, and you can see it probably, it's wobbling a little bit in there. And see in the center, it kind of goes away. That's okay. That's all right. Like I said, we're not going to go nuts here, for sure. What I like to do with this guy, and when you do this, by the way, make sure the cutter is at the center of the piece you're cutting. just to make my life easier, I like to have this go automatically. So to do this, you got these little levers and knobs and buttons down here. You got to crank this thing here to make it turn, the screw turn. It's for threading actually, but it also makes nice thing when you're turning things smaller. So let's see here. Let's stop that, Wayne. So put this up to go this way. So put this up there. There we go. Crank it away. And that's a little bit slower than I want.
About that.
Nice and easy as pie. Again, too bad I can't make pie. So hopefully you can see that okay. And a nice clean rod. And I'm just doing the first cut on it. The one that he already has is, remember, is about 210 thousandths, 215. So if I take, remember, if the diameter of this thing is 250 and I cut 10, okay, how much if I take it off? I'm gonna take off 20. So you gotta be a little bit careful about how much you cut off. So if you took 5 thousandths off here, and move this in 5 thousandths, it actually takes 10 thousandths off. It's like simple math. So we're gonna go a little bit and see how she looks. I don't know why I'm doing this. I'm doing it because it's practice actually. It's outside micrometers, what they call it. It'll help me just check how thick this thing really is. I could use calipers. The calipers are not the best way of doing it. They're not that accurate. But it doesn't matter. It's for the sawmill. You do want to stop this thing from turning before it crashes into the 3-jaw chuck, because otherwise you will be embarrassed. So the point is, pay attention. There we go. All right, so the way this gig works is 0.1, 0.2, 0.3, 0.4 thousandths, blah, blah, blah. Each of these, a full revolution is 25 thousandths. So there's 4 click marks between it. So I'll show you how this works real quick and easy. Crank this on here, put it on here till it's snug, not tight. And what do we get? Well, if this was 250 thousandths like the original one was, would be right here at 250. Let me just show you that. About. Check that out. About 250. So this is smaller, obviously. So what do we got here? So now we're 10 thousandths. We have a 15 showing. So we were at 225. Now we're 10 thousandths smaller. So there you go. So now we're at 240. So I'll go a little bit more. I'll go another 5 thousandths, 10 thousandths. Do a couple cuts here and see what happens. I'm not sure I like the way this is working. I mean, it'll be fine, but it's got some wobble to it. The wobble doesn't help it any, but the reality is it doesn't make a lot of difference. So we'll just let her go and see what she looks like. And there's some advantages to wearing eyeglasses all your life, because these little birdie things flying away, chips, could get you in the eye. You'd be a one-eyed person. That would be bad. All right, let me put the camera back so I can pay attention here. There we go. How's that? There's one more cut. And let's see what this is now. Looks to me to be 225. That's exactly right, 225. That's actually not bad. That's about what we have now. 225 approximately. A bit rougher than I'd like it to be right here, but I don't know, it makes a whole lot of difference. Polish it up so it looks nice. Don't put your fingers too close to the cylinder because that'll hurt. And let's take a peek at what we got here. Ooh, it's nice, shiny. Pretty smooth, relatively smooth, not perfect. But for what we're doing, it's probably going to be good enough, I think. All right, so we are not working. On a space shuttle here, remember. So what we're going to do here is figure out about where to put a bend on this thing. So let me get my marker. And the way I look at it, by my rough estimates, it's got a bend at about 2 1/4. So why don't I do the same thing? Bend it at 2 1/4. So we'll do this here. And let's see what we can do. Let's take you over to the VAV, which is the big ass vise, and give it a little crank and see what happens. Alrighty, so here we are, 2 1/4 up. And then we take our BAH, which is our big American hammer. I want to make sure this thing is vertical here. If it's not vertical, so make sure that's vertical. Good. Take your big American hammer and tap, tap, tap. Let's see what happens. Look at that. That looks pretty good. Alrighty. Looks pretty good. Now, these are 1, 2, 3 blocks. Since I've got them, I might as well use them. Let's take a look. It could go a little bit more, actually. Just let me hit it a couple more times. Not much, though. Oh, does that look nice? Ooh-wee. Oops. Looks pretty good to me. It's a little bit cockeyed, so what I might do is straighten out some just by going like this. Alrighty, so the next bend has got to be about 1 inch. And actually, let's see here. That's an important bend. So I should actually measure it. What? Yeah, we're going to measure it. So it's 1 1/8 actually. Look at this. Looking at it this way, 1 1/16. So the way I'm measuring this is from the start here to the end here. And we will get 1 1/16. So that's what you want. And that's actually an important number because if I screw that up, I'll just cry. No, it's only kidding. So let me take this other one out now so I can get ready to figure that. Alrighty, so here's what we got here. I'm gonna take this thing and bend it somehow. How am I gonna do that and get the exact same? I'm gonna bend this one. How am I gonna get the exact right size? Well, it turns out, I swear to God, I just pulled this block out and there you go. See how thick that is? Perfect. And that's the right size. So this is gonna be my template. So what we're gonna do here is we will secure this onto here with a vise or clamp or something like, oh, C-clamp right here. I think I'll use vice grips on a C-clamp. Bang it down, bang a gong, and then we're good to go. Alrighty, clamp her down to there and give it a little bit of tap tap and see what she looks like. The goal is to have it be about this same thickness there. But now I know why this was 0.210 with 40 thousandths clearance, because if this angle's not right, it ain't gonna work right. But let's give it a shot and see what happens. Watch your eyes. She's getting there just fine. Watch your toes, girls. But now, interesting, what a smart man would do is squeeze it in a vise, and then it'll be perfect. And I think I can do that without a whole lot of effort. So I'm getting close. And the nice thing about this block, it's almost big enough to put right in there. So let's see what happens here. Let's see. Maybe not quite big enough. That's where I put it. Let's see here. Bend here, didn't want. Let me think about this, how to get this better. Aha, about like that. That's a better way of doing it, isn't it? Yes, sir. I took a short bus to school, but we'll figure it out. Yeah, actually, that's pretty good. I like that a lot. Okay. Just a little bit more. What are the chances? It looks pretty good, actually. This isn't quite right, but nothing a little bit of hammering will not figure out. So, and that's what I'm really good at, just hammering and banging. Just kidding. Let's try this guy out and see what she does. How about that? Miracle. Okay. Maybe a little bit more. Ready? Good. Oh, does it look good? Probably way too big, but I'll find out shortly. Let's see what we got here. Now, how long do we want to make it? We'll go back and do another precise measurement. Stand by. So actually, I cut this end off here. This is kind of what we wanted to do. So when I pull it out, you can put it through the bit. It looks pretty good, and actually it goes in and out a little bit. Now, it didn't go in and out quite the way I was hoping at first. A little bit bang, 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 tap, tap, tap with hammer and vise, and we're good to go. But now, how do we prevent this thing from coming out? That's easy. I'll either peen this over or weld a little nub on there. I'm not quite sure what. Let me think about that a second. I'm thinking. All right, my brain, I'm done thinking. What I want to do is, Pete had some tape on this, and that's not a bad idea. That's the easy way of doing it. But what I'll do is I'm going to take this rod here, and I'm going to take it, drill it out, 1/4 inch. I'll cut off 1/4 inch washer, put it on here, tack it on with a welder. We'll be good to go, and I'll be done. So let me get on that. All right, so when you're drilling a hole into a small piece of stock like this, any piece of stock like this with a lathe, the chuck's gonna wobble. It's kind of loose already. So what you wanna do is you get one of these little center cutting bits here like this, crank that bad boy in there and get it started. And I'm gonna drill a 1/4 inch hole in this guy. So let's do that. All right, make sure everything's clear. Crank this guy down. This you have to have a little bit loose, otherwise it locks it in. But let's crank it up and let's let it rip here, Chip. And this will find the perfect center of this piece of material. There you go. How's that? Easy as pie. A little bit further. What is that? That's how to do that. We don't want to drop that. But. Now back this bad boy up. Take this out and put a 1/4 inch bit in there. All right, if I wanted a perfect diameter hole in here, you'd use a boring bar. I'm gonna use a drill bit because I'm lazy, but I'm using these stubby drill bits, these little short ones, and they have less movement. And also when you put it in the chuck here, put it in as far as you can. That way it won't wobble as much. There you go. That's the story. I'm sticking with it. Crank it a little bit. We may end up getting a little bit of oil on this. Let me, I think we're good. Good, good. Hands clear, clear. A little bit of oil. Especially in steel and steel. And I'm cutting 15/64 instead of a 1/4 inch right off the bat. Just a little bit smaller. All right, so now I put the cutoff tool on here and cut off a little piece. Cutoff tool has to be at the right altitude, otherwise not a problem. All I'm trying to do is get a little washer in here, so this is not critical. Tight, tight, tight. Watch your eyes. If I can zoom in on that, it's kind of cool. A little bit of Earl on that thing, and we'll let it rip, tater chip. Now the good news is these don't go flying; it'll just like drop. Man, it's getting really rough. And I see it. Miracle. All right. Let's see. Be careful. It could be hot. All right. So now I got my little washer on here. It's a snug fit, as I was hoping. But I'm going to tap it down a little bit. And then we're going to tack it on with a motor. And we'll call it quits. Of course, I've got this nice vise. I can squeeze it too. Of course, that might screw up the alignment. Maybe I don't want to do that. Try this one more time. Oh, look at that. Beauteous. I'm probably wasting my time welding it on. So what we're looking for here is this has got to come out this far. Because if it doesn't come out that far, it won't work. But it does. So now we're going to TIG weld this on. We're going to call it quits. We'll be done with one after I check to make sure I did this right. All right, guys, you probably won't be able to see this at all. I don't know, but it's kind of an experiment. So I got this washer I put on here at the end. It's a press fit, so it probably is never going to go anywhere in our lifetime. Regardless, I might as well either Loctite it or TIG it on. And since we're here, well, Loctite's right up there, I can Loctite it. We'll just put a little bit of some heat on it and melt it into place. So I'm not a TIG welder, that's for sure, but I've done it a couple times, so what the heck. All we gotta do is get some heat. DC, of course, gas turned on, purge it out a little bit, let it rip, tater chip. Hopefully you can see this. Of course, my piece is shaking like crazy. I'm not, the piece is. Ooh, does that look nice? I'll put a little bit more metal in there. Beauteous. And for once in my life, I didn't smash it into the electrode. I didn't smash it into my tungsten, wrecking my tungsten. So my tungsten still looks good. Sweet. Probably too much heat, but that's the way it goes. I'm done. Project over. Maybe I'll cool this off a little bit before I touch my fingers to it. It's nice and warm. Okay, well there's one of these tools fixed. I got 2 more to go. This one came out pretty good. I'm not sure though I want to do the other ones quite the same way. It was a little bit hard to get the two pieces of steel bent exactly perpendicular and parallel and all that stuff so that they fit through the holes properly. So I may do it a little bit differently. I may measure the holes, and I might just cut a little plate on the mill, and then we'll have them perfectly set and ready to go. We'll see how it goes. Thank you so much for watching. Hope you enjoyed this. This is kind of a different video than I normally do. If you liked it, give it a thumbs up, hit subscribe, leave a comment, blah, 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 all that good stuff. Try and help me out a little bit, guys. I'm not getting a whole lot more subscribers anymore. We did hit the 1,000 mark a little while ago, but I want to keep going up. I want to be like Hoovie's Garage and Fireball Tool and some of these guys. No, just kidding. Well, not really. I would like to get more subscribers, so do me a favor, hit subscribe. It's free. Thanks a lot, guys. Take care.